So
There we go.
can you
Awesome.
hear and see me? And
Yep,
can you
we
see
can
my
see you
screen?
and we can hear you and we can see your screen. The
Awesome.
trifecta. There we go.
Okay. All right. So I'm going to do an overview of RAT's ecosystem. So let's jump into that. Okay, just quick overview of the working group. It essentially started in 2019. The working group was formed, and it was first chartered to focus on architecture and evidence formats. And then in 2022, it was rechartered to focus also on protocols and mechanisms for conveying attestation information, and also on definition of some of the other inputs to the verifier, which we will call the endorsements and reference values. I think you've already had an overview of RAT's architecture from Hank, is that correct?
That's correct. That is correct.
Okay. So that's so then in 2023, the IETF seat working group was formed, which is focusing on TLS and DTLS and attestation, and you just heard Osama's talk on that. And then just to highlight some of the other things going on, so like in the LAMPS working group, which is focusing on PKICS related stuff, there are a couple of attestation related efforts going on there. So an attested certificate enrollment. There's another group which is focusing on trusted execution environment provisioning, where it has a TIPA protocol which has an attestation component integrated into it. The suit working group, which is focusing on firmware updates, has attestation support, and there's also some work going on in the OPSAWG group, which is defining Yang models. That those models also are doing attested posture assessment. And then the OAuth working group is doing attested clients as a precondition to token issuance. And OAuth is the group that's primarily defining and using web tokens. And there's other stuff going on. I don't know if I can keep track of everything that's going on in all of the groups, but that's kind of a rough overview of things that are going on. So any questions about that? All right, so let's do kind of an overview of attestation to get some context. A lot of what we in the RATS working group spent time on was defining attestation and defining terminology before we could even begin with an architecture. And the name of the group is, the R in the RATS name is for remote. So remote attestation procedures is the full name of the working group. And essentially, it's saying that trust is a function of device composition integrity. That's kind of the fundamental premise for where you derive trust or how trust is derived. But there's other stuff going on in the industry. So for example, content attestation, where trust is a function of the content value chain integrity. And some examples, an example here is the CTPA effort that you may be familiar with. And then there's also, as I'm sure you're aware, supply chain attestation, which is also called supply chain provenance, where trust is a function of the supply chain integrity. And an example here is the in toto work. So the kind of the overlap of all three of them is where I think trust sort of ends up at the end of the day for attestation. You combine all them in some meaningful way. And I think that's when you sort of get the nirvana of attestation at that point. And so there have been some discussions about sort of how does attestation fit in the overall big picture of things. And, we have, authentication, authorization, audit, access control. It seems like there's yet another A to add to the list, which would be attestation. So if you sort of put that into a layer cake, I think you have authentication at the bottom layer. So identification, authentication, bottom layer. Then I think you get the attestation layer, and then you can layer the other things on top. Maybe it's authorization, access control, that sort of thing. But that hasn't really been formalized anywhere in IETF or sort of anybody that's in charge of defining security layering architectures. So I think it's early days in terms of getting that level of understanding around attestation. So any thoughts or questions on that one? I'll jump to the next slide. It's not just jump in anytime if you have a question. Okay, so this is meant to be a brief overview of RATS architecture, but if Hank has already covered this, I'm not going to belabor it. I did this mostly to introduce the terminology because the next slide kind of buckets the different work that's going on in the RATS working group based on kind of how it fits in the architecture. So I'm going to move on unless somebody has a question. So what's going on? Basically, there's 6 buckets that we can talk about: architecture, policy, and then the different roles: the attester, the verifier, endorser, and reference value provider, and relying party, or I called it attestation results because relying party kind of wears 2 hats. So in the architecture, we have, of course, RATS architecture, RFC 9334. There's another kind of follow-on architecture document called RATS endorsements that's still a draft, but making its way. There is another draft called direct anonymous attestation. This is focusing on using DAA, which is a zero knowledge proof based algorithm or group signing algorithm. So the intention there is to help preserve privacy better. There's another draft, which I guess it fits in the architecture bucket, called reference interaction models. It's essentially providing some stereotype request response kind of interactions for like how you would exchange information over a RESTful interface. And then we have 2 other drafts, 2 other RFCs that are focused on TPM. So we have the challenge response remote attestation with the TPM. It's an informational RFC. It's providing some connective tissue and trying to helping folks understand what role the TPM plays in the sort of broader internet in terms of attestation. But otherwise, it's technology that's been around for a long time. And then there's the remote verification of network device with a TPM, and this is focusing more on integration of attestation in network equipment like routers and so forth. And so any questions about that? All right, so I'm gonna...
So before you move on, and this is, so I'm somewhat familiar, but many people in the room may not be. So for people who want to become involved in this, how do they sort of get involved in the IETF? How do they get involved in some of these work streams?
Basically, IETF is open to anybody. Doesn't cost anything to participate. It's just a matter of starting to participate. Sign up to join the list, the email list. Every working group has an email list. You can just subscribe to that. The one thing that you'll need to be aware of is what their IP policy is, and that you understand that when you make a contribution, it falls under their IP rules. But it's there isn't like the notion that anything that you contribute is available it's generally available and broadly available. It's not, you're agreeing to live by those rules. But otherwise, anybody can join and participate, and participation is, you know, based on an individual. So you don't join as a company per se. But yeah, it's pretty easy to get involved if you want to get involved.
Yeah, it's also, and I will say this as somebody who became involved some years ago, you can start simply by joining the mailing lists and watching what's happening. And it's often quite a good idea to watch for a while because they're fairly active, and you quickly learn a lot from the expertise of people online. So it's most recommended. Sorry for the interruption. Carry on, Ned.
Sure. I will say that a lot of the work also happens in GitHub repos where, you know, people writing a draft, there'll be typically what happens is there's like a design team. Somebody will have a great idea for a draft. They'll garner support from whoever's interested. They'll form a design team and they'll start working on the draft. And they'll probably do that in GitHub, in which case it's a public GitHub. If somebody else is interested, they can join in on the GitHub and read what's going on there, submit issues, or even become an author, you know, if they have more to contribute. It's that sort of thing. And then there's sort of more of a formal process to move it from an individual repo on a GitHub into the data tracker, which is the IETF's location for work that they're working on, and you sort of formally hand that over to become a repo under the control of the working group. And that's when you sort of have the name change from, you know, draft IETF something or other. But everything's public and open, and anybody can contribute at any stage if they want, basically. The short answer. All right. So moving on. So let's talk about a tester. There's most of the stuff that's going on is in the attester bucket because that's where the charter was initially focused. The first RFC so the first work item that got through that is something called Entity Attestation Token. It's essentially an extension to web tokens, so CWT, JWT, that are, you know, attestation relevant. Going hand in hand with that is the EAT media types RFC, which defines, as you might expect, media types for you know, EAT payloads. And then there's also sort of related to that is unprotected CBAR web token, or UCCS. It was observed early on that the CWT RFCs were only meaningful or only defined for signed web token for signed web tokens. So there wasn't the ability to have an unsigned web token. So this RFC goes back and says, here's what an unsigned web token looks like and how you can use it. So that was thought to be useful in the context of, say, EAT, where you could have an unsigned EAT token that's been incorporated into an existing secure channel, maybe TLS, and there's no need to, or, you know, at least it's thought to be not necessary to have to add another layer of signatures if you have a secure channel. That's why that's there. Then there's something called conceptual message wrapper. It's getting, this one is probably the next one that will go to RFC status. And this is a wrapper structure for a payload that is an attestation message. So if you think of if we go back to this slide here, all of the, you know, endorsements, reference values, evidence, and so forth, those are considered conceptual messages in the architecture. And so the thought was, hey, we need sort of a wrapper structure to put around anything that is a conceptual message. And in particular, what it does is it identifies the type of conceptual message that it is. It's, you know, one of those what, 6 or 7 messages. And it also defines the ability to have a signature, so you could have a COS or JOSC signature around the wrapper if you wanted. But that's otherwise that's there's not much to it besides that. Then we have another draft called EAT Measure Components. This is adding some additional claims to what would otherwise be an EAT token. The focus here is on describing some additional aspects of what an attester might have to present in an attestation token. There's work going on that's related to the LAMPS working group, which is a PKIX evidence structure, and the focus here is mostly on HSM community. So this is, if I have an HSM that's doing an attestation, what is it that an HSM has to say about itself? Kind of conversation that's ongoing. Excuse me. And then we also have the network device subscription draft. It's essentially publish subscribe for attestation, so that's kind of interesting. And there's others. On the next slide, I have a list of new work or potential new work, but what I'm showing you here is work that's been adopted by the working group already. So that's attester stuff. So that's essentially, evidence that feeds input to a verifier. There's other inputs to the verifier, like endorsements and reference values. There's work going on here. There's something called Concise Reference Integrity Manifest, which is defining a format for representing endorsements and reference values. It also includes a reference model for a verifier. So I've kind of separated that out and put that into the verifier section there. The reference verifier and internal representation for CORIM, which is section 9 of that CORIM spec. There's ongoing discussion about that spec, and some folks are suggesting that they break it into two specs. So it might be broken along those lines. I don't know. Then there's something called Concise Trust Anchor Stores. This is adding another essentially payload to what could be carried by a CORIM structure, and it's focusing on defining trust anchors. That hasn't seen a lot of activity recently, so I'm not sure if that's moving forward. Now, incidentally, you could also use EAT as a endorsement or reference value container. So I've included that here as well as the conceptual message wrapper could be used in this context also. Moving on to the verifier, there's something called the Concise Selector for Endorsements and Reference Values, or COSERV. This is basically defining an interface between the verifier and endorser RVP community that enables the verifier to select or essentially discover and obtain endorsements and reference value structures for feeding into the verifier. There's another draft called that we refer to as epoch markers. This is defining essentially a epoch marker based nonce mechanism, and that is also been around for a while, but getting some traction and moving forward. And then moving on to evidence transformation. This is a draft which is defining, for example, a mapping from various evidence formats that exist in the industry to the internal representation that's being defined in the CORIM Section 9. So SPDM measurement block is an example of some some evidence formats that exist in the DMTF. There's also a format called from the TCG DICE working group, which encodes evidence as in a structure called DICE TCB info, which can be an extension of a certificate. That's being just that transformation is described there. And then there's also another thing from TCG called the concise evidence format, and so there's a transformation method that's being defined there. The idea being that with this reference verifier internal representation is that all of the various formats for evidence, endorsement, reference values, and so forth have to be mapped to something that all verifiers can process. And so there's essentially a schema translation step to make sure that's done in a reasonable way. So if you are reading through the RATS architecture, you'll probably get to a section that talks about something we refer to as the bow tie diagram, which is essentially describing the complexity, a component of complexity having to do with having multiple, formats of the different information that a verifier might consume, and that extends to working with legacy stuff as well. So it sort of looks like a bow tie if you look at the diagram. So that's explained there. I won't go into too much detail. So moving on, the next is attestation results, which is kind of the output from the verifier to the relying party community. There we have two drafts. One is called the attestation results for secure interactions. It is essentially defining an abstraction or aggregation of the verifiers, the result of the verifier's analysis can then be abstracted into a set of weighted values that are describing kind of the level of trust, if you will. And then attestation, EAT attestation results is another draft, which is building on the AR4SI concept, but defining the set of values that you would put into an EAT token that can then be signed and supplied to a relying party in a secure way. So that's kind of the high level overview. I have a slide on what's kind of potentially coming up in terms of not yet adopted stuff, and then I have a couple of slides that go into more detail on some of these other drafts. But I can take questions if there are any.
So any questions either online or in the room? I'm not seeing anything, so I'll thank you for that, Ned, and point out that I thought I knew what was going on in RATS more or less, and there were a couple of things on here I hadn't spotted. So
okay, and here's the laundry list of new stuff, which you probably have, which people are trying to get their hands around this stuff, right? So just so I can go through that, but jump in if you have questions. So we have. Or do a time check. I wasn't paying attention when I started.
Yeah, we'll need to be pretty quick, I think. So yeah.
Okay. Well, I'll just run through this, and then we can see if there's any questions. But so this is the list of potential next things to work on. So something called remote attestation with multiple verifiers. So this is taking the concept of I have a single verifier. I want to split the work up in different ways. How do I do that? There's something called the taxonomy of composite attesters, which is taking a closer look at how do I decompose the attester in some meaningful way and recompose it again by the verifier, so that it can essentially walk the composition and not get lost trying to figure out how a device is composed. Another draft is focusing on the integration of remote attestation with key negotiation and key distribution. So this is just saying how does key management work in the context of attestation. So that's one of the newer ones. I don't know that I have my arms fully around that one. There's also been some discussion about geographic attestation results, which is incorporating the notion of location into the mix. There's a proof of position for auditor managed endorsements, which is thinking of ways of representing location, or at least think of it as regions, like how to sort of represent whether a device is in a particular region, and what are the implications of that from an auditor's perspective. There's work going on in trusted path routing, which is focusing on attestation in the routing context, and how to essentially build a trusted routing path. There's some work around distributed remote attestation, which is taking the idea of multiple nodes in like a workflow and ensuring those are attested. We have a neat profile for device attestation. So one of the things that's going on, I'm going to kind of up level a little bit. So if you start with say in a format, say you start with an EAT structure, and a particular vendor discovers that they have some values that are not representable easily with what's in the standard, a profile can be defined that allows vendor specific extensions. And so there's you'll see some drafts that are individual drafts that are doing this sort of thing. So Intel has one, ARM has a couple, there was AMD had one, and it's basically providing this ability for vendor specific extension to address kind of architecture specific needs. So that's mostly what you see on this site over here. And then let's see, yeah, there's some work on key attestation as opposed to environment attestation. If you look at a lot of what's been defined already, it's been defined from the perspective that you're attesting an environment. And then some folks have said, hey, I care about keys and we want to attest keys. So it's flipping that a little bit and saying, what are the properties, attestable properties of the key? And we're also, someone is proposing some work to be done related to agentic AI systems. So lots of interesting stuff going on. So I didn't know if people were going to want to go deeper in any of these topics, so I prepared some notes to do that. But certainly, if people have questions, they can ask them, and we can dive into whatever, however depth you want with the time that we have. But otherwise, this is my concluding slide. So yeah, RATS has been around for 6 years and continues to be lots of work going on there, lots of new work being proposed, lots of existing work being done, lots of collaboration with other working groups, both within the IETF and outside. and other working groups, including, you know, the list that you see here.
Okay, that's great. Any questions before we finish up? I'll mention while I'm looking to see around the room and online. So Global Platform also has adopted EAT and effectively has developed what the IETF would call a profile. We can call a configuration for attesting global platform environments. Not yet published, but will be published quite soon.
Okay.
I'm not seeing any questions, so I'll thank you very much, Ned, for your
Sure.
for contributing and thanks for taking the time.